Today we are going to discuss about method of joints for a truss section or to analyze forces in the members of a truss section. Okay, let this be our example. Okay, this is a simple truss. Simple truss usually consists of 5 members. Okay, let this be point A, B, C and D. Let this support truss be simply supported, which means hinged and roller support. The length of the members be 3 meters and 4 meters, which makes the diagonal 5 meters. Let's take loads. At point C there is a vertical load of 40 kilonewton, and let's keep a same 40 kilonewton horizontal load at the point C. We know that for a hinged support there will be two reactions, some vertical at A and horizontal at A. This is vertical at D. Since this is a roller support, there will be only one vertical at D. Now we have three equilibrium equations. Sigma H is equal to 0, sigma V is equal to 0, sigma M is equal to 0. From the first equilibrium equation we can directly say that HA is equal to 40, as there are no other horizontal forces. HA is equal to 40 kilonewton directly. Now second equilibrium equation is sigma V is equal to 0. From sigma V is equal to 0, VA plus VD is equal to minus 40, as the 40 is acting in the upward direction. Now from the third equilibrium equation, let's take moment about point D. So moments about point D is force into perpendicular distance up to these points. The forces available are VA, HA, 40, 40 and VD. Let's take VA. Up to point D, the force is acting in the clockwise direction. So VA into 3, and the perpendicular distance from this to this is 0, because this is in the same line. Now perpendicular distance from this load to this point is again 0, and all the remaining load is 40, and it is acting in the clockwise direction with respect to point D. That is again plus 40 into 4 is equal to 0. So VA is equal to 40 into 4, that is 160 by 3. This gives us 53.33 kilonewtons. Okay, from this, substituting this, we'll be getting this is minus 53.33 kilonewton, and substituting this, we'll be getting VD is equal to 13.33 kilonewtons. Okay, now draw the free body diagram. Okay, the free body diagram is the diagram which we represent only the forces in the members, nothing else. So the supports will be representing as VA is minus 53.33, that is in the downward direction, plus 53.33 kilonewton, and HA is 40 kilonewton, and next VD is plus 13.33 kilonewton, and the loads are 40 and 40 kilonewton. Okay, the supports A or joints A, B, C, D, lengths 3 meter, 4 meter, 5 meter. So this diagram we represented like this. Now the second step is to assume. Let's assume all the members to be either in compression or in tension. Let's take them as in tension. I'm just assuming, so you can take it either in compression also. Just for my sake, I am taking them as in tension. Okay, assume all members to be in tension. Okay, these are called joints and these are called members. now simply all we need to do is take each and individual joint and then do sigma H is equal to 0, sigma V is equal to 0. Now we have to remember is we have two equilibrium equations and we need 2 unknowns at the maximum. If we take joint B, we will be having 1, 2, 3 unknowns. So starting, we cannot take joint B. See, the same problem goes to joint D. There are 3 unknowns. Now, if we take joint A or joint C, there are only 2 unknowns. So let's start the problem by taking joint A. Okay. Now, joint A. So joint A is this part. Okay. Now take here, represent the forces 53.33 and 40, and this member force in member A, D. See the direction here, the same direction I am writing here. Okay. Now upward force in member A, B. See the direction here, the same direction I am representing here. Now take sigma H is equal to 0, I will be getting force in member AD is equal to 40 kilonewton. Since this is in the positive sign, the direction which I am assumed is correct. So this will be 40 kilonewton tensile. Now next, force in member AB is equal to, this will be sigma V is equal to 0, and this will be 50 kilonewton. Force in member AB is equal to 53.33 kilonewton. Again, since the sign is positive, the direction which I have assumed is positive. So this one is positive, that gives me 53.3 kilonewton. Again, tensile. Okay. Now let's take joint C. So I can take any joint I want. For example, if I take joint B, there are 3 unknowns and there is 1 inclined member, which makes the calculation slightly difficult. So in order for the problem to be solved easier, I am considering this joint. So the joint is C. So I can take joint D and B also, but for the sake of convenience, I am going with joint C. Okay. So the joint C is 40 horizontal, 40 vertical, and this will be the same direction which I have assumed. This will be force in member CD, and this is force in member BC. Okay. Now sigma H is equal to 0, sigma V is equal to 0. Just substitute in the two equilibrium equations. If we take sigma H is equal to 0, we will be getting FBC is equal to 40 kilonewton. Since the sign obtained is positive, what we have assumed is correct. This will be 40 kilonewton tensile. Now sigma V is equal to 0, FCD is equal to 40 kilonewton. Again, sign is positive, what we have assumed is correct. So they will be getting FCD as 40 kilonewton tensile, FBC 40 kilonewton tensile, FAB 53.33 kilonewton tensile, FAD 40 kilonewton tensile. Now all that is remaining is force in the member BD. In order to do that, we can take either joint D or joint B. If we take joint D, there is one more vertical force, that is 13.33. I will avoid it for the sake of convenience. I will be taking joint B. If I take joint B, there are no other forces, which means the direction in a horizontal force is 0. So let this be F in BC, force in BD, force in AB. Okay, let this one be angle theta. Let's take sigma H is equal to 0. That gives a force in member BC plus force in member BD into this inclined member resolving horizontally is cos theta. Okay, if you are having trouble with remembering this, just remember it as the angle adjacent to theta will always be resolving into cos theta, that is equal to 0, since there is no force in this direction. So FBC is 40 kilonewton. So just take it directly, 40 plus FBD is unknown, and cos theta based on this triangle. So we have assumed theta here. Cos theta is adjacent side by hypotenuse. Adjacent side is 3, hypotenuse is 5. So that will be 3 by 5 is equal to 0. So force in member BD is equal to minus 40 into 5 by 3, that is will go minus 200 by 3. This will be minus 66.66 kilonewton. Okay, now you need to see is here we got negative sign, which means the direction which we have assumed initially is wrong. So we have assumed this to be in tensile direction, so actually this will be in compressive direction. Okay, so this is FBD 66.66 kilonewton compressive. So this is how we calculate member forces in any given truss section by using method of joints.